Okay, this is the second portion of 1-1 day 2. I didn't want to cram this in. I only had like 2 minutes left. I gotta fit this in and make sure it's clear. So I wanted to make sure I had time. So with that being said, there are going to be questions, and the concept we're covering is called rate of change. Now you guys have been you've been hit with this for a long time. Basically, it's slope. But it's a different way that this particular Algebra 2 curriculum wants to discuss slope. They want you not only to understand slope, they assume you know how to find slope. I'll take a few seconds to kind of review that, but not long. What they want you to do is understand by looking at rate of change, which is just another way of saying slope of a graph, you're supposed to be able to determine whether it's a linear, I've been hitting that hard, what's a root word of linear? Line. What's a line? It's very consistent, it's constant. So you'll notice something. This is the activity the book wants you to do, but it's simpler than that. But just in case the language gets a little confusing, like the expectations, what am I supposed to do? I want you to know what the book's expectations are. I want to make it really simple, but I don't want you to ignore this video once you go, oh, I get it. So I'm just going to go on to my next video. But I want you to look at this. It's a line. You know what that means? The rate of change is constant. Okay? Now, that tells you it's a linear function. Same thing here. That's a line, a straight line. And then you can just look at this and you're like, that ain't no line. That's a parabola. There's a curve in it. All that they really want you to do is experiment with rate of change, which is another word for slope, to determine whether or not something's linear or not. Now again, you can just look at it. Yep, yep, no. Remember, linear means straight line. This is a quadratic. Yeah, it's a line, but it's curved. So that's why it's considered quadratic. Now the exercise that the book wants you to understand is practicing slope, which what you notice here, let's go to example 1. I've already done all the work for you, but it's probably overwhelming. But this right here is from A to B. So B is x2, y2. Now I'm not going to do this for all these. So this right here is x2, y2. It's the second point. And then that means this right here, A, would be x1, y1. And so this is x1, y1. And all you have to do is take these pieces, plug it into that formula, which is what I've done, and then I come up with 0 for the slope. Remember, slope by definition is rise over run. Well, there is no rise from this point to that point. There is no rise from this point to that point. So I'm going to have a 0 in the top every time. See that? And then the run is right here, 0, which according to our formula is x sub 2, which you get from here, minus x sub 1, which is negative 2. You got to look out for those double negatives. That's 0 plus 2. That's why it's a positive 2. So basically, I did the slope formula from point A to B, 0. 0 slope. From A to C, 0 slope. From B to C, 0 slope. Notice, 0, 0, 0. The book says, aha, because these are all the same, this is a linear function. They also call this a constant function because it's a flat line. So they add this language for a flat line. Not necessary, but I just want you to get familiar with the way the book calls things. So be prepared for that. This is not a constant linear function, even though the slopes are the same. That's why I don't want you to be confused, because it's on an angle. Only these flat lines are considered constant by the book. So I want to just iron out some wrinkles of language that could potentially be confusing. Notice from A to B, I'm not going to show you all my work, I get slope 1/3. That's from here to here. From A to C, so from here to here, if I plug these values in to that formula, I get 1/3. If I do the same thing from B to C, I get the same thing. Yes, it's a linear function, because all my slopes are the same. Now I go to this quadratic, and this is where it gets a little interesting. This is probably something you haven't seen before, but from A to B, so I'm figuring out what the slope of that line is right there. I'm still using the slope formula. I'm not finding the slope of this. I'm finding the slope of this. Notice, after I go from A to B, so here's my x2, y2, because that's what I'm going to, and this is my x1, y1. If I plug it in appropriately, which I've done, I get slope 2. Then if I go from A to C, I'll get a different colored marker out for you. From A to C, plug things in, and I get 3. As you can see, the slopes are different. That means this is not linear. I believe that's all the book wants you to understand. It's not linear. It's not consistent. Slopes change. But I'd like it if you'd also know that it is quadratic. Get used to that term. It's a parabola. That means my variable is squared, which is what makes it curved. There you go, you guys.